Hi folks, welcome back to Math with Captain Ron. I'm making this video here to help finish up your notes about the application problems in section 15.2 over quadratics. So looking at the, let's see what would be, I guess, the third one on this sheet where it says, I'm going to read it exactly, the height in feet s of a ball thrown upward at an initial speed of 62 feet per second from a platform 40 feet high is given by the function s equals minus 16t squared plus 62t plus 40. Where t is in seconds. Find the maximum height above the ground that the ball will rise. So I kind of overviewed it here. Again, hopefully you have your sheet here in front of you. So when they say find the maximum height, this function is describing the height. Specifically, the variable s here is representing the height. And we're trying to find the maximum value of that. So I'm going to write this function over here. S of t is equal to minus 16t squared plus 62t plus 40. And in order to maximize this, we're looking for the vertex. Now remember, standard form of a parabola. Y equals a times x minus h squared plus k. Now this is the standard form in terms of y and x. Here we got in terms of s and t. So, effectively this is an s and this is a t, but the method is still the same. We want to try to write this as t minus something, the quantity squared. First step is going to be to factor, that's negative 16 from both of these terms. So that first term, that's going to give us a t squared, and the next one, oh boy, okay, so this is going to give us a 3.87 if I try to do it that way. So I'm going to do, let's write this minus 62 over 16t. We'll just do that. Okay, this product now, you'll notice, is still positive 62. We'll leave ourselves a little space for what are we going to add to make this a perfect square, and then the plus 40 over on the right. All right, these ones with these tougher numbers can be a little bit trickier, but just follow the method here. All right, we take a look at this. We cut it in half. That would be 62 over 32, and then we square it. So right here we're going to put 62 over 32, the quantity squared. Then we have to maintain equality here. Effectively, what we just added was negative 16 times this. So over here I'm going to put positive 16 times this same expression, 62 over 32, the quantity squared. Just, when these numbers get kind of tough, just follow the procedure for, the easy ones. The same procedure applies to all of these problems. All right, so equals minus 16 times this now, by design, is equal to t minus 62 over 32, the quantity squared. You can tell what this guy is going to be here by looking right here. Remember that last term, whatever's here has to square and give you this. So it's got to be 62 over 32. Plus, okay, now let's deal with this. And I'm just going to get a value here now. Let's see. Okay, my calculator's in kind of decimal mode here. It gave me 1601 over 16. That's what, about 100? So I'll just put it plus 100. All right, so what have we learned here? Well, this function, s of t, is parabolic because of the squared. It opens down. If I were to do a quick sketch, real quick, you'll notice that if I put t equals 0 in, I get plus 40. This one starts up here. It's looking something like this. We're not going to need this intercept to answer the question. The vertex is here, and it is at the point 62 over 32, 100. The 62 over 32 is the time. I mean, if we actually wanted a decimal, right, 1.93. Or 1.9, I guess that rounds to 1.94. 100. So the maximum value is 100 feet, if I've worked this problem correctly. So I think I'll pause this and get the next one set up. All right, folks, I'm back. And take a look at the next one down. The next one was identical to the one we just did, so I chose to skip that and move to this one because it's slightly different. So the next one says, a manufacturer of DVD players believes that the revenue the company receives is related to the price of the recorder by the function given by this. So the R is representing revenue as a function of price. What price? So we're looking for P here, the price. What price will give the maximum revenue? All right, so we're looking for the value of P that will maximize this function. All right, so first of all, maybe just a quick sketch here, real quick. Revenue against price. Well, you notice if you put P equals 0 in, you get 0 out. This goes through 0, 0, meaning that if there's, we give them away, there's no revenue. No doubt there's some value over here, and I could find it, but I'm not even going to need it. There's some value over here where that crosses again. That's because if something is so overpriced, they're not going to sell any. You're not going to sell any cans of soda if they're $100 a can, right? This function opens down because the thing in front of the P squared is negative. So this function is likely looking something like this. And we're looking for the value of P where the revenue is a maximum. All right, so let's start looking for that. So we've got R of P is equal to, and I'm going to rearrange this. Let's write it minus P squared over 4 plus 50P. And again, what we're going to have to do is kind of put this in its standard form. I'm going to write that down. X minus H squared plus K. All right, now this one doesn't have Y's and X's. It has R's and P's, but still standard form. This stuff still applies. Let's factor this minus 1/4 out of these two terms. Here we're going to have a P squared plus, okay, now when we factor a 1/4 out of the 50, I believe that's going to make that minus 200. Minus 200p, leave ourselves some space. Just remember that this times this has to give you this. 200 over 4 is 50. We're good. All right. Now, okay, we have to complete the square. You look here. You don't really need to include the minus sign. You can if you want, but I'll go ahead and do that. Minus 200. You cut that in half. That's minus 100. Then you square it. That's 10,000. So, and again, here's why you don't really need to worry about the minus sign. When you take this value, whether it's positive or negative, and square it, you're getting a positive value anyway. So we're going to put plus 10,000 here. Now we have to maintain equality. What we really added was 10,000 times minus 1/4. So over here I'm going to put plus 1/4 times 10,000 to maintain equality. All right, so minus 1/4 times. This will now factor into P minus 100, the quantity squared. All right, and then 10,000 over 4, I think that's 2,500. 25, whoops, I put one too many zeros on that. Times 4, yep. All right, now, I imagine people probably have a little trouble going from here to here. I always just remember this, all right? It's going to be P minus something. You tell the something by looking here. Remember that this thing squared has to give you this. So this guy is always going to be the square root of this guy. That's why it's 100. All right, so the vertex of this function we found, right, just kind of comparing P minus 100 to X minus H. The H is 100, and the K is 2,500. So that's the coordinates of the vertex. To answer the question, it says what price will give the maximum. So the price is $100. Although it doesn't actually say that's in dollars, I assume they mean that P was in dollars. So the price is $100, and then that revenue would be 2,500 bucks. So I hope that these video sets help you out with these application problems. Have a great day.